learners, welcome to SWIM online lecture series on database management system. I am Muhammad Ubaidullah Bukhari, professor in the Department of Computer Science, Aligarh Muslim University, Aligarh. I am pleased to have you join me today as we explore the fascinating realm of database and database management system. In the next few minutes, we will journey through concurrency control, which will enhance the knowledge for design of modern information technology. In the previous lecture, I have discussed about the relational decomposition, lossless decomposition, and the lossy decomposition. Decomposition is naturally a very important part in the database. First of all, you have to check a relation is normalized or not. If database is not normalized, then we have to decompose. So how you will check? We have to check the three anomalies. First, updation anomalies, insertion anomalies, and deletion anomalies. If these three anomalies will satisfy, then we can say that the database is normalized. If it will not satisfy, then we can say that the database, the relation is normalized, so we have to decompose the relation. In the previous lecture, I have discussed about the decomposition. That decomposition must be lossless and FD preserved. We are not losing any tuples, and also we are not losing any attributes. It must be lossless and FD preserved. It means when you are decomposing, there are four situations will arise. 2 about 2. It means four situations will be arises. It may be lossy and FD preserving. It may be lossy and non-FD preserving. It may be lossless and FD preserving. In lossless, non-FD preserving. If your decomposition is lossless and FD preserving, then we can say this is a normalized database. In the previous lecture, I've already discussed in detail. So decomposition is a very important, and depending on the requirement of your organization, you have to decompose it in a smaller table, and then you have to check all the three anomalies: insertion, deletion, updation. If it is certified, then we can say this is normalized. Then no need further decompositions. Before going to today's agenda, I would like to discuss the answer of the previous questions which I have given you in the last lecture. The first question was, what do you mean by lossless decomposition, and explain it in detail. Lossless decomposition ensures that when we split a data into a smaller table during the normalization process, we do not lose any information. This means that all the data from the original table is preserved across the smaller tables. It's like taking apart a puzzle and being able to put it back together exactly as it was before. Lossless decomposition is crucial in database design because it guarantees that we can reconstruct the original table accurately, maintaining data integrity and consistency. The next question, describe lossless decomposition. In contrast to lossless decomposition, Lossy decomposition involves splitting a table into smaller tables but potentially losing some information in the process. This loss of information might occur because we deliberately discard certain data to simplify the database structure or reduce redundancy. For example, we might choose to remove duplicate rows or columns that are not necessary for the database functionality. While lossy decomposition can save storage space and streamline database operations, it comes with the risk of losing valuable data that could be important for certain queries or imply. Next question: what are the advantages of lossy decomposition? Lossy decomposition offers several benefits such as reducing redundancy and conserving storage space by eliminating unnecessary data. By getting rid of redundant or irrelevant information, we can streamline the database structure and make it more efficient to manage. Additionally, lossy decomposition can simply database queries and analysis by analyze by focusing only on the essential data, which can improve performance and speed up processing time. However, it is essential to careful consideration the trade-off and potential implications of losing data before implementing a lossy decomposition strategy. The next and the last question was, what are the advantages and disadvantages of lossless decompositions? Lossless decomposition ensures data integrity and maintains all the information present in the original table across the smaller table. This guarantees that no data is lost or altered during the information process, which is critical for preserving the accuracy and consistency of the database. With lossless decomposition, we can confidently perform relational database operations like join and merges without worrying about losing any data. Additionally, lossless decomposition supports database scalability and flexibility, allowing us to modify and expand the data structure while preserving its integrity. The today agenda will discuss about the introduction of concurrency control, understanding locking mechanism, transaction isolation level, two-phase commit protocols, deadlock detections on prevention, optimistic concurrency control, multi-version concurrency control in NoSQL database, exploring isolation anomalies in database transactions, impact of concurrency control on database performance. So we start introduction to concurrency control. It means concurrency control in transactions ensure that multiple transactions can execute concurrently without causing data inconsistency. It involves techniques like locking, timestamps, multi-versioning to protect conflict and maintain database integrity. Main purpose is to maintain database integrity and, prevent conflict by using locking, timestamps, and multi-versions. The concurrency control it involves a different types of techniques. This ensures data consistency and reliability in multi-user environment, crucial for efficient and scalable data operations. Then the advantage of concurrency control is the improved performance, enhanced scalability, improved performance allows multiple transactions to execute concurrently, maximizing the utilization of a system resources and reducing idle time, improving overall system throughput and responsiveness. Enhanced scalability means enabling concurrent execution of transactions. Concurrency control of facilitate the scaling of database to accommodate increasing workload and user demand without sacrificing performance. It means he can balance for more large database and large users also. The next is increased concurrency. This is a very important of advantage of concurrency control is increased concurrency. In concurrency control mechanism enable multiple users to access and manipulate shared data simultaneously, enhancing users concurrency and supporting a large number of concurrent users accessing a database concurrently. The last is data consistency. Data consistency ensures the concurrent transactions do not interface with each other, maintaining data consistency and integrity. So next is disadvantage of concurrency control. Overheads, potential for deadlocks, reduced throughputs. These are the advantage. These are the disadvantage of concurrency control. So implementing concurrency control mechanism introduce additional overhead in terms of processing, resource utilization, locking, time stamping, or versioning mechanism can consume system resource and increase transaction processing time. So overload will be increased. Potential for deadlocks. Concurrency control mechanism, particularly those based on locking, can lead to deadlock situation where transactions are unable to proceed due to conflicting resource locks. Deadlocks can result in system slowdown or even system crash if not properly managed. So potential for deadlocks also the advantage. Reduced throughput. In high concurrence, reduced throughput, complexity will be also increased, risk of starvation. Complexity means concurrency control mechanisms add complexity to database system, requiring careful design, implementation, you can say, and also maintenance. Understanding and managing concurrency issues can challenging, particularly in large scale distributed system, and then risk of starvation. Transaction isolation levels. There are some steps: read uncommitted, read committed, repeatable read, and serializable. Read uncommitted, this is the lowest isolation level, where transaction can see uncommitted changes made by other transactions. It offers the high concurrency but may lead to dirty reads, non-repeatable reads, and phantom reads. Read committed, in this isolation level, transaction can only see committed changes made by other transactions. It prevents dirty reads. But may still result in non-repeatable reads and phantom reads. And the third is repeatable read level. In this level, repeatable read level ensure that within a transaction, the same query will always return the same set of results regardless of change made by the other transaction. It prevents dirty reads, non-repeatable reads, but may still allow phantom reads. So there are four. And the last is serializable, is the highest isolation level of transactions are committed isolated from each other. Their efforts, it prevents all concurrency related anomalies, including dirty reads, non-repeatable reads, and phantom reads, but may lead to decreased concurrency and increased contention. The next topic is two-phase commit protocol. Two-phase commit protocol, we can say 2PC, is a mechanism used in database management system to ensure the atomicity and durability of transactions that span multiple databases or system. It involves two main phases. First phase is prepare phase, the next is commit phase. In prepare phase, the transaction coordinator, usually the DBMS or middleware, asks all participating databases if they are ready to commit the transaction. Each database responds with either a yes or no answer. The next is commit phase. If all participating database responds with a yes during the prepare phase, the transaction coordinator sends a commit message to all of them, instructing them to make the transactions change permanent. If any database records with a no or if there is a failure in communication, the coordinator sends a message, an abort message to all databases, instructing them to roll back the transactions and undo any changes made. Then deadlock protection and prevention is also very important. The deadlock detection and prevention is also very important topic in the time of designing database. Deadlock detection and prevention is non-distributed database management system, involves understanding and addressing situation where the multiple transactions are waiting for resources held by each other, resulting in a deadlock. Deadlocks can occur when transaction acquires locks on the resources in a way that prevent other transactions from proceeding, leading to a it will lead to a standstill. Next is detection and prevention techniques. Prevention techniques focuses on designing transaction scheduling and locking strategies to minimize the likelihood of deadlock occurrence, such as using a strict locking hierarchies or timeout mechanism. We have to add. Next is optimistic concurrency control. Optimistic concurrency control is concurrency control techniques used in database management system to allow multiple transactions to operate concurrently with minimal locking. In optimistic concurrency control, transactions processed without acquiring locks on database object initially. Instead, each transaction reads the database state at the beginning and records the relevant data, for example, using timestamps or version numbers. The next, when the transaction is ready to commit, it rereads the data to check if the changes have occurred. If the data has not changed since the initial read, the transaction commits successfully. So, optimistic concurrency control suit for environmental where the conflicts are infrequent and the cost of acquiring and releasing locks is high. So in this way, optimistic concurrency control can improve the concurrency and reduce the contention, leading to better performance in system with low transaction conflicts rate. The next is multi-version concurrency control, MVCC. Multi-version concurrency control is a concurrency control techniques used in database management system to allow multiple transactions to read and write data concurrently without blocking each other. Multi-version concurrency control, each transaction sees a consistent snapshot of database at the time if it began, regardless of other transaction changes. When transaction writes data, it creates a new version of data rather than overwriting the existing version. So the next topic, concurrency control in NoSQL databases. Automatic concurrency control. NoSQL databases often use OCC to allow multiple transactions to proceed concurrently without blocking each other. It means in concurrency, I mean to say that in optimistic concurrency control, transaction operates on local copies of data and only check for conflict at the time of commit. If conflicts are detected, the transaction is aborted and retired. In concurrency control in NoSQL database, version-based concurrency controls. Some NoSQL database, particularly those that support multi-version concurrency control, maintain multiple versions of data item to support concurrent read and writes. Conflict resolution. NoSQL database may use conflict resolution mechanisms to handle conflicts that arise from concurrent update to the same data item. Conflict resolution strategies vary depending on the database type's consistency model, but often involves merging conflicting changes or selecting a winning version based on the timestamp or other criteria. Also, concurrency control in NoSQL use distributed locking. In distributed NoSQL database, distributed locking mechanism may be used to coordinate access to shared resource across the multiple nodes. Then we'll discuss by exploring isolation anomalies in database transactions. So there are dirty read, non-repeatable reads, phantom reads. We will discuss about the exploring isolation anomalies in database. Dirty read. A dirty read occurs when transaction read data that has been modified by another transaction but not yet committed. If the modifying transaction is later rolled back, the changes are lost, resulting in reading transaction accessing invalid or incorrect data. So next is non-repeatable read. A non-repeatable read happens when a transaction reads the same data multiple times within its execution but obtain different results each time. Phantom reads occurs when a transaction executes a query multiple times and obtain different set of data each time. So this happens when another transaction insert or delete rows that match the query criteria between the execution leading to unexpected result. It means there are three expressions: dirty reads, non-repeatable reads, and phantom reads. Then we have to discuss impact of concurrency control on data performance. Concurrency, by that it will improve the performance, database performance. So the first is improved throughput. Effective concurrency control mechanism can increase the number of concurrent transactions that can be processed simultaneously, hereby improving overall system throughputs. So by that concurrency control, the performance will be improved. The next is reduce response time also. We can reduce the response time. Concurrency control techniques that minimize the locking overheads contention can help to reduce the transaction response time. Increase executability and overhead and contentions. Concurrency control mechanism can also introduce overhead and contentions. And the last is complexity and maintenance. So by that improve complexity and maintenance. Also implementing and managing concurrency control add complexity to the database system. It requires careful design, configurations, and tuning to the ensure optimal performance while maintaining data consistency and integrity. In our explorations, we have navigated the integrated world of concurrency control in detail. I hope you enjoyed this exploration. Thank you very much.